so it can be put into a fraction.
Yeah.
I usually use m over n.
Okay. Okay. And what's next? So we assume.
Which it would square it, so it has 2 equals squared over n squared.
Yeah. So m over n, and where m and n have no common factors. So basically it's in its simplest form. So you square both of them, you get m squared over n squared.
Yeah.
And what would you do after that?
Would be times across the n squared.
Yes, so that was equal to root 2. Maybe I'll just do that first. Over n equals root 2. And so, yeah, and when you times across, what do you get?
We'll have 2 n squared.
So m
is equal to m squared.
To n squared.
And then I'm not sure what to do after that.
Off the top of my head, let's see. I think. Yes. So basically, 2n squared must be even because it's times 2.
Yeah.
So m squared must be even. And so, but that creates a problem. But m over n has no common factors. This is a contradiction. Therefore, we've proven it. So, therefore, root 2 is irrational. So, the way this works is you say that m over n is in its simplest form, so there's no common factor. But if they're both even numbers, then it's not in its simplest form. You could half the top and half the bottom.
Okay.
So, let me just make sure. So that was it, yeah. So a squared must be even, so a is also even. Yeah, a squared is even, so a is even. If a is even, then it can be expressed. Yeah, hang on. This means that b squared must be even. Let me just see. Becomes, which means 4n squared. If a is even, then it can be expressed in the form a equals 2n. Oh, maybe we should have subbed that in. So a squared is equal to 2b squared becomes 2n squared. Let me just check. A squared must be even. If a is even, a is 2n, sub 2n for a. Yeah, okay, so they just did it with a little extra step. Let's see, so these were these questions. I'll just see if I have. Oh, we can just do the root 3 one, I suppose. What was your one? The cube root of 2, was it?
Yeah, I think that was it.
Okay. So let's try this.
So would we assume that it would be rational and be put into m over n?
Yeah, so we assume that the cube root of root 2 is equal to m over n. where m and n are integers with no common factors.
Would we cube?
So cube both sides. What do you get?
So it'd be 2 over m cubed over n cubed.
N cubed. Okay.
Would I then times the n cubed to 2?
Yeah.
So if m cubed is a factor of 2,
Mm-hmm. 2n cubed is even because it's times by 2.
yeah. Does this mean m cubed has to be even?
Yep. So m cubed is even.
And then because they're both even, they've got common.
I would go further than that and say so m is even because
Okay.
actually we have to show that m and n are even, not m cubed and n cubed, I think. So m is even.
So then would we say that because they're even, they have common factors?
How can you write any even number?
Oh, can we write 2n?
Yeah. Written in the form 2n. And then you can sub that in.
Okay.
Oh, sorry.
So,
sorry. We used m and n. Yeah, this is why I use a and b. So let's use 2k.
okay. So if it's 2k cubed,
Yeah.
so then would we have 2n cubed is 8k cubed?
Mm-hmm.
Do I divide it by 2?
Yeah.
So if n cubed is divisible, or can I say if it's even?
Yeah, and just to spell it out, I'll just say because it's times 2. So yeah.
Yeah.
N cubed is even. N cubed is a factor of 2.
So then n has to be.
Yeah. Yeah, so now we've shown that m is even and we've shown that n is even.
So then we've proven by contradiction.
Yeah, so
that root 2 must be irrational.
Yeah, and we would just have to say that by saying, so like m and n have a common factor of 2, but m and n are integers that have no common factors, and that's a contradiction. And so we've proven the opposite.
Okay.
Yeah. M and n, yes. Common factor 2, but m and n have no common factors. Contradiction, therefore irrational. Yeah, so we assume that it is rational. We kind of take that to its logical conclusion. We get a contradiction, and so we know it must not be true. So the big picture for these ones is like squaring both sides, cubing both sides, showing that one of them is even, writing that in the form of 2k, subbing it in and showing that the other one is even, which means if they're both even, then they can both be simplified. They both have a common factor, but we've said that they don't have a common factor, and that's a contradiction.
Okay.
And that's how you do all those. Any questions with that?
No.
Okay. Do you want to do more of these, or you think you get it? You want to do something else, or?
I think I understand that one now.
Okay.
I think I had another proof question.
Uh-huh.
And it was saying about like consecutive numbers.
Oh yeah, what did you have to prove?
I think it was like n, but I think it was to try and say it was divisible by 6.
And do you remember like what exactly it was, or?
Not really, but I think it was using oh, I know, there was one that was saying about if n was like even and odd, and using things like that.
So okay, so how can you write any even number?
Like 2n.
Yeah. How can you write any odd number?
2m plus 1.
And so that's usually how you go about those. It might have been something like the square of an odd number and an even number.
Yeah.
So how could you show that? How could you find the square of an odd number and even number?
So can we square the 2m plus 1?
Yeah. And for even number?
It would just be 2n squared.
Yeah, so you just square them both, and let's say it's the sum of their squares. So we'll add them or something. Okay, what do you get there?
That's 4n squared. And is that 4n squared plus 4n plus 1?
Yes, and it could be a proof like show that so that's 8n squared plus 4n plus 1, and the proof could be show that the sum of the squares of two consecutive like odd, even, and not two consecutive numbers is always one more than a multiple of 4. So how would you show that you get a multiple of like one more than a multiple of 4?
Could we factorize it into brackets?
Yes. So what would that be?
Can we stick 2 on the outside?
That would be to show that it's an even number, a multiple of 2. What if we wanted a multiple of 4?
Can we put 4 on the outside then?
Yeah.
Then 2n squared. And then plus n.
Yeah. And so you have a multiple of 4, regardless of what n is, because we did it for all possible numbers, all even numbers, all odd numbers.
Yeah.
So the sum of the sum of the squares of 2 consecutive numbers is always one more than a multiple of 4. Do you know how you would write 2 consecutive odd numbers?
Would it be like 2n plus 1 and 2n plus 3?
Yes, exactly. So that would be 2n plus 1 and 2n plus 3. And they might ask you something about that, like show that the difference between the sum of the squares is something, and maybe this time it would be minus or something. And I put the bigger one first. So let's see. So this one will be 9 minus 1 is 8. And in the middle you get 12 and 4. So that's 8. 8n. That one's not too bad. Yes. And you could show that the difference between the square of 2 consecutive odd numbers is a multiple of 8 by doing it that way.
Okay.
But I'm just I don't know exactly what the question was, but if they say it's a multiple of 6, then your final answer will have like a 6, and then a bracket. And consecutive odd numbers, 2n plus 1, 2n plus 3. Consecutive even numbers would be 2n and 2n plus 2.
Okay.
Any questions there?
No.
Okay. Anything else of those things?
I think maybe just practice some more proofs.
Okay. So I'll see if I can find some that are a bit like that. Proof by contradiction, so that you just find one. It must be a multiple of 3. We could try this one if you like. Is this worth doing?
So we can write n as like 3k.
Yeah. N is a multiple of 3. Okay, so let n be equal to 3k.
So if we square that, so because it's n squared. So then we have n squared is equal to 9k squared.
Yeah, I think it might be the other way though. It says n squared is a multiple of 3, so I think we would let n squared be equal to 3k. So the problem there, let's see, if n squared is a multiple of 3, if n squared is a multiple of 3, n is a multiple of 3. Okay. Okay, we could do it the other way. So n squared equals 9k. Alright, how do we go about this one?
If 9's... Could you say that 9 is a factor for 3?
It is. I think if we're proving this by contradiction, then we could do something else. So we could do something like let n. How could you write something that's not a multiple of 3.
You can use 2k.
So by coincidence, though, you have like 6, 12. Those are in both times tables.
Yeah.
You could do something like 3k plus 1. And then you could square that. And so we know for a fact that 3k plus 1 is definitely not in the 3 times table.
So could we expand that?
Mm-hmm.
So that is n squared is equal to 9k squared. 6k plus 1.
Okay, so this is not a multiple of 3, and I believe this is not a multiple of 3. We could also try let n be equal to 3. Can you think of another number that won't be another way of expressing a number not in the 3 times table?
Could you do 4k?
See, again, you have 12. That would be in both.
Oh.
I'd do like
Can you just leave it as k? Or is it has to be?
I'll do 3k plus 2.
Okay. So then that would be 9k squared. Then have we got 12?
So that's 12k.
And then plus 4.
And then plus 4. So that's not in the 3 times table either. And then 3k is what we did. So I think we've tried all 3. Because if we do 3k plus 3, then that goes back to being in the 3 times table again. So you can factorize out 3. If n squared is a multiple of 3, n is a multiple of 3. So we said, so we would assume, what do we have to assume here? We would assume that n squared is a multiple of 3. Say if, then n is not a multiple of 3.
Okay.
So what we saw was, so that's multiple 3, multiple 3. So this one shows that if it's one is not, the other is not. No, I just want to check this one. Oh, I don't have one. Okay, assumption. Yes, so our assumption is correct. There exists a number n such that n squared is a multiple of 3, but n is not a multiple of 3. All multiples of 3 can be written as 3k. Therefore, 3k plus 1 and 3k plus 2 are not multiples of 3. So n is 3k plus 1. We get that. That's not a multiple of 3. N is 3k plus 2. Yes. In this case, n squared is not a multiple of 3. This contradicts the assumption that n squared is a multiple of 3. Oh, this is like, it's kind of like proof by exhaustion. We just tried all possibilities. So if n squared is a multiple of 3, then n is not a multiple of 3. So the numbers that are not multiples of 3, there's only 2. There's 3k plus 1 and 3k plus 2. We tried them both. Neither of them gave us a multiple of 3, and so no such number exists. Aha. So, how did they just say the end part? Yeah, in this case, yeah, so basically for the first one, n is not a multiple of 3. of 3. Nor is n squared. And then same thing for this one again. Multiple of 3. Nor is n squared. I'd say this is even like proof by exhaustion.
Okay.
Therefore, no such number exists. Yeah, so we should have gotten one of them to give us an n squared that was a multiple of 3. There wasn't, and so there's no such possibility.
Okay.
Any questions about that?
No.
Okay. Anything to do with like a multiple of 3, multiple of 4, you could show that it's not a multiple. Yeah, because it's contradiction, so show it's not a multiple. And are we okay for B? It's the same as what we did?
Yeah, that is just proving it as it is rational, and we can put as m over n.
Yep. I just want to look at the exam questions. This is an exam question. Irrational. Those ones are the same thing. A, B. You just write them as one thing over another and multiply them. Proof by contradiction. Let me see this one. Yeah, okay, let's try this one. It's very similar.
So if we assume that if n squared is even, that n is odd.
Yeah.
So if we used 2n plus 1 for n, or 2k, sorry.
Yeah.
So if we squared that, so that's 4k squared plus 4k plus 1.
And how do we... okay, what's next?
If it's even, it can be divisible by 2. And that would leave it as 2k squared plus 2k, which is a half then.
And so I just leave that like that.
Yeah.
So it's one more than an even number.
So that would mean it's not.
Yeah. So therefore, n squared is odd. I think that's the contradiction, isn't it?
Yeah.
Contradiction, therefore n must be even. Yeah. So n squared will also be even.
So that proves...
so I wrote down therefore n must be even.
Okay, yeah.
To get an even n squared.
Yeah.
Just copy and paste. Therefore, if n squared is even, then n must be even. So let's take a look. There exists a number n such that n squared is even, but n is odd. N is odd, so it can be written as 2k plus 1. N squared is 2 times 2k squared plus 2k plus 1. So n is odd. N squared is odd. This contradicts the assumption. Therefore, yeah, copy and paste.
Okay.
Any questions about that?
No.
Okay. And that's that's pretty much year 2 proof. It uses those same things over and over again, like even 2k, odd 2k plus 1, consecutive odd 2k plus 1, 2k plus 3. What was the other one? Yeah, irrational a over b, where a and b are integers with no common factors, meaning it can't be simplified. And then irrational 1, yeah, square both sides, show that they're both even, so they do have it. Yeah. I can find more questions for this if you want, or we can do something else.
I can't think of another topic at the moment.
I can check. I can just go. Do you know how you differentiate trig?
I know sin x goes to cos x,
Yeah.
and cos goes to minus sin x.
Yeah. Oops. And this is a minus cos.
So would that be a positive sign?
Yes. So that would be 6 cos x plus. It's going to be a positive sign. And what would that be when you differentiate it? 3 cos 2x.
Would it just be minus? Oh wait, no, it'd still be positive.
Yeah. And what will the numbers be?
Is it 3 and 2? Is it still the same?
So this will be 2x. You have to use the chain rule and differentiate the function inside the function. So what is the function inside the function? And what's the derivative of it?
I can't quite remember.
So this part is the function inside the function, 2x. And so what's the derivative of 2x?
Just 2.
And so you times it by 2.
Okay.
And so that becomes 6 sine 2x. That is 6 cos x. And how do you find stationary points?
Is that when x is 0? Or the whole thing is equal to 0?
Yeah, it's when the derivative is equal to 0, and then you just solve it from there.
Okay.
We'll just focus on the differentiation part. Okay, how do we go about this?
So the 6 sine 2x, would that go to 6 cos 2x times by 2?
Mm-hmm.
So that's 12 cos 2x.
Mm-hmm.
And then is that add?
Mm-hmm.
Would it be 8 sine 2x?
Well done. And for this question, we wanted to find the equation of the normal. Any idea how you'd go about that? What will you do next?
I'm not quite sure.
So if the other way we found the derivative,
Yeah.
you would then sub in x1 to get the gradient at that point.
Okay.
And so what is x1 for this?
So is that going to be just 12 cos times by 2?
It's not when x is 1. It's the x coordinate.
Oh, by pi.
Yes. And so you do the g dash of pi.
So is this going to be in radians?
Yeah.
I've got that to equal 12.
Oh, I should have used X. Hang on. Shift pi. So I've put it into my calculator. So d by dx. So shift integrate. And I just put in the original one. So 6 sine 2x minus 4 cos. Sorry, I put in pi instead of x. Minus 4 cos 2x. And x equals pi. And I also get 12.
Okay.
And so in general, like if they want you to give you the derivative, you would find the derivative. If you just need the gradient, then you would use, I would just use the calculator. And so we're asked for the normal. So how do we go about that?
Is that going to be a perpendicular?
Yes. And so what will happen there?
Will it be negative 12?
Negative reciprocal. Negative 1 over 12.
Okay, yeah.
So the equation of the normal in general, the other way it's like y minus y1 equals x minus x1.
Yeah.
So in general, so they're using the g of x. So to get the y coordinate, it's the g of x1. But in this case, they already told us it's minus 4, so that's not too bad. M, or in this case for the normal, it's the negative of 1 over the g dash of x1. And that's x minus x1. So for these, you just have to find the g of x1, which is just the y coordinate. I'll just write that in the bracket. And find minus 1 over g dash of x1. And then you sub them in. Sum them both into y minus y1 equals mx minus x1. And use the calculator if you can.
So for this, would the y be y minus 4?
Yeah. And the reason why, if you put pi into this up here, you will get minus 4.
Okay.
And so if they don't give you the y coordinate, you have to get it yourself, and that gives you the y, so y minus y1, and then the m is always minus 1 over what you get when you sub x into the gradient function.
And then, so inside the brackets, the x1 would be pi.
Yeah.
Okay.
And so same as year 1 stuff, but now they're just using weirder stuff like pi.
Okay.
Any other questions there?
No.
Okay. Is it worth? Let's just see this one. So they said the x coordinate is pi over 2. Is it worth trying to see what gradient you get using your calculator?
Yeah. How would I do that?
So is yours graphical?
Yeah.
So I'll switch to graphical. I think it's math and then d by dx. So 1 for a matrix, F4 for math, and then d by dx.
Okay, yeah.
And so 3 sine x, so 3 sine, and then just use the x on the left above the fraction button. Minus 4 cos x plus 1 over 2, press right, x squared. And what do we put into the little box next to the x equals?
So that'd be pi over 2.
Yeah.
Is it?
Yeah. Pi over 2.
I've got 5.57.
Aha. Am I in a different thing? I'm in degrees. Okay. And you're in radians, is it?
I think so, yeah.
Okay. Yeah. And so I should change to your one. Let me just see something for a second. Yes. So for this one, we could. Hang on. With x coordinate is this. Yes. For this question, we could use that to check our answer. In the previous question, they asked for the equation of the normal. The gradient was minus 1 over 12. I used my calculator. I got 12. You did it manually and only put it in afterwards. You also got 12. For this one, our calculator didn't give us an exact value. And you can see here they want an exact value, like 4 pi, 16 pi.
Yeah.
And so this is the type where we'd have to do it manually. But so this one would we could use it to check our answer, but unfortunately, yeah, they pick questions to kind of force you to do it manually. Any questions there?
No.
Okay, so to differentiate with a calculator, math, d by dx, and then put it in with x1. Let's see. So this stuff, very, very similar. Find the equation of the tangent. If you had to do this, you could do the same thing again. If it gives you an exact answer, great. Or in fact, they didn't ask for an exact answer. You could do d by dx of 2 to the x plus 2 to the minus x, and then sub in 2.
Okay.
And that would give you the m, and then you already have the y, and you already have the x. So y minus 17 over 4 equals the answer in the calculator, x minus 2.
Okay.
And if it doesn't give you an exact answer, then you have to do it manually. Do you know how you differentiate these ones?
I know when you differentiate e to the power of x, it stays the same.
Yeah. Any idea what the derivative of e to the 2x would be?
Would it be e to the 2x? Then times by 2.
Well done. Yeah. And so that can be written as 2e to the 2x. Any idea what the derivative of ln x is?
Is it 1 over x?
Yeah. 1 over x. That's it. That's good. And then you just sub in their x value. This was one where they wanted an exact answer, like e squared. The calculator will give a decimal for that.
Okay.
And then you just sub in 1. Let's kind of skip that stuff. Chain rule is what we were just doing, where you multiply by the derivative of the function inside the function. So let's try. Well, alright, how would you do this one?
So either we could put it into the calculator.
Yep. And what if it didn't give us an exact value? How would we do it manually?
We could change it so it was 5x squared plus 1 to the power of a half. And then differentiate it that way.
Okay.
So it would be a half, bring the half down, and then it'd be 5x squared plus 1. and then the power would be minus a half.
Mm-hmm.
So then we would
Yep.
do we input that when x is 4 and it's equal to 9?
You still have to multiply it by the function inside the function.
Oh, so would that be 10x?
Yes. And so just watch out for that. Yeah, and then you would sub in 4. So that'll be fine. Hang on. That's kind of a different thing. Let me just see something.
Yeah.
This one. Yeah. I just want to see. That one's a little weird trick. Okay, how would we do this one?
So if we differentiated, would we just have 3 and then brackets 5 minus 2x, and then that would be squared, and then is it minus 2?
Yeah. So times minus 2, so that becomes minus 6. But even then, you don't even really need to simplify it because you're just going to put it into your calculator anyway.
Okay.
X coordinate of 1, so you'd sub in 1. And this looks like the type, let's say m equals minus 6, 5 minus 2 times 1 squared. 5 minus 2 is 3. 3 squared is 9. 9 times 6, that's minus 54. So this looks like the type of thing that the calculator would get an exact value for.
Okay.
So that's chain rule. So differentiate and then multiply by the equation, by the derivative of the function inside the function. In this case, what's the function inside the function? Or how would you go about it?
Would it be, is it like u dash v minus
that's
v dash?
That's if you have an x on the top.
Oh, I'm not quite sure. So, or do we times the bottom to the top? So it becomes minus 3?
Yeah. So your other way would work. It would just be a longer, more challenging way. Yeah, you would do that. Differentiate it. What's that going to be? Minus 9. 6 minus x to the minus 4.
Yeah.
And then times by?
Minus 1.
Yeah. And so that's the function inside the function. There's lots of those. Lots and lots. But it's the same thing. Chain rule, function inside the function. Product rule. U v dash plus v u dash. How do we do this?
Is this one maybe have to split it?
Yeah.
So our u we can say is x squared. So u dashed would be just 2x. And then v, we can have 3x to the minus 1 to have half. And then would v dash be a half brackets 3x minus 1 to the minus 1?
To the minus a half?
Oh yeah, to the minus half. And then is that just 3?
Times by 3, yeah.
Times by 3.
Yep.
Is then...
So same as that. Yeah, go on.
So if we times the u, so that's x squared times by the 3 over 2 brackets 3x minus 1 to a minus a half.
Yeah.
And then is that plus v,
Mm-hmm.
and then times by 2x.
Yeah. Times by 2x. That's it. And I wouldn't make it any simpler. Like you can you can factorize 3x minus 1 and you can factorize x and stuff, but I wouldn't bother because they're just going to say the x coordinate is, 7, find the gradient, and you'll just sub 7 for x.
Okay.
And in fact, I'd probably use a calculator and differentiate back from there in case you made some mistake here.
Okay.
So that's the product rule. We didn't get to quotient rule, but I think you have an idea for quotient rule. It's when you have one function divided by another function.
Okay.
And you have all your proof stuff. Yeah. Yeah. How was that for you, Eva?
That was good, thank you.
Anything in particular you want to do next time?
I don't think so. I think I'm supposed to be getting my exams back this week.
Okay. And
so.
And I should call on this Skype, is it usually?
Yeah.
Okay. Sorry, I was calling the other one. Any questions for me in general?
No, thank you.
All right. Well done, Eva. You did great, and I look forward to chatting again next week.
Thank you.
Right, have a good week. Goodbye.
Bye.